apart, and then under certain conditions, perhaps a drop in temperature or increase in moisture or other environmental change, they'll invest their energy into making the mushroom. So I'm often trying to explain this and then talk about how this mycelium connects up to trees. And so I often do this little demonstration where I talk about, let's imagine we're all now coming down underneath the soil, and this little poster tube represents a rootlet, a very small root on a tree on the end of a larger root, magnified probably about, I don't know, 400 or 500 times. It's basically a tube. Okay, so it's a tube, the root's basically transporting nutrients and water to the tree. Is that how you understood a root system? I mean, it also anchors the tree, but it's pretty much transporting water, transporting nutrients. What they didn't tell me is that trees actually aren't very good at it, okay? What the tree, of course, needs is its fungal partner, the mycelial partner, to form the mycorrhizal relationship. And I'm not going to tell you this, but don't tell Britt that I've still got his pantyhose collection. And we use these to represent the fungal mycelium. So let's just imagine again, we're under the soil, the root is under the soil, it's looking around for nutrients and water, but you know what, they're pretty clumsy, clunky things. They can't get into all those tiny interstitial spaces, the gaps and cracks and pores in among the sand particles, and extract enough water and nutrients. What of course they need is the fungal partner to form that ectomycorrhizal symbiosis, the sheath around the root. Can I get you to grab that? Don't worry, Britt washes them meticulously. Thank you. Can I get you to grab a mycelial? Thank you very, very much. That's great. Thank you. Cheers. Whoops. Oh, a bit of mycelium. There we go. So I sort of do this demonstration to explain to people, of course it's crude, of course metaphors always simplify things. That's what metaphors do. They make something that's complicated or abstract a little bit more accessible. So again, we're under the soil, here's the tree root. It's now got its ectomycorrhizal fungal partner, ecto meaning external. Fungus attaches this externally to the root. We also know some actually endomycorrhizal or avascular mycorrhizal fungi actually penetrate the cortical cells of the root, but with most of our eucalypts, there's some that are avascular, mostly the ectomycorrhizal. Ecto, myco always means fungus, rhizal means root, symbiosis means relationship or alliance. And we know that, of course, that the mycelium can actually expand out that absorbable surface area of the root system hundreds of times, maybe even 1,000 times. We're still doing the research on this, trying to understand how expansive it is, how significant it is, but we know that it's not only expanding out the root system, it's probably about 1/40th of the width of a human hair. It's much, much finer than the finest root, so it's got much more reach. It can get into all those pores and spaces that the big clunky old root can't actually penetrate. So it's got much more reach within the soil. It's also got a cache of enzymes that help it break down organic matter, transport the nutrients back, transport the water back to the tree, and in return, in this mutually beneficial relationship, the tree gives the fungus a lovely feed of sugars that it produces through photosynthesis. And of course, where this becomes even more astonishingly arcane, we know that this tree doesn't just have one mycorrhizal fungus, it can have hundreds of different fungi that do different things and connect up to different trees. And some of you might have read Suzanne Simard's book, Finding the Mother Tree, or maybe one of Peter Boll-Leven's book where they talk about the wood wide web, this interconnected network of trees being connected up by mycorrhizal networks. And I think Susan quoted an average, what she called a hub tree or a mother tree, one of the larger or older trees in the forest. I think on average the median was 37 trees. Am I remembering that correctly?
40 years. I heard 40.
40, okay, it's a lot. And that was kind of quite a mind-blowing revelation. And I know since this book came out, and I know that what's often happened is, journals love this idea, they pick it up and they run with it, and the science hasn't quite caught up. We don't really fully understand which trees are connecting and how much carbon's being transported. We don't really understand the significance. A lot of this work is done in the lab. We don't know fully how it plays out in the field, so there's been quite a lot of kickback, and that this notion of the wood wide web is perhaps just getting a little bit carried away with itself. But despite that, it really helped me, and a lot of other people, I think, simply recognise the interconnectedness of systems. And I think back to when I was a child, and I'd go along to what we called the Field Naturalist Club. This was a group of people who are interested in nature. We go out in the spring and we make lists of all the orchids we see. Find an orchid we identify, we make a list. And then we go down to the coast and we make a list of all the intertidal organisms that we could recognise. And then in the fall we go to the forest to make a list of all the fungi. And this was great for me. I was like 7, you know, I'd go out and I'd learn to identify them, we'd have all these lists. But what no one ever said, when I say, oh, this is a truffle fungus I've just found, and they'd write the name down and pop it on the list, but no one ever said to me, okay, see those holes there? That's something called a beton that's been digging for the truffle, and that truffle is connected to these eucalypts. No one ever sort of explained you've got this this cross-kingdom interrelationship going on. They're always just lone statute, isolated entities in the forest. And I think for me to recognise, you know, finally when someone said this is interconnectivity, it completely changed the way I thought about how systems operate, even if we don't fully understand the extent of it. And I was doing this little demonstration to this group of people in Western Switzerland once, and one of the women said, I have no idea about this. This is amazing. She said, my sister lives over the border in Besançon in France, and she runs a creche. Could you come along and talk to these children about ectomycorrhizal symbiosis and mycelium network? I'm like, a creche? Like, little kids, do you not think that ectomycorrhizal symbiosis and mycelium networks and things is a little complicated? Couldn't we wait another 10 years? I mean, aren't they a little bit young? How old are kids in Canada? What are they, 3 or 4 or something? I don't know how old they are. And she looked at me and she said, don't be ridiculous. These are French children. I went, oh. And she said, just bring your stocking and your pantyhose, you'll be right. So I thought, I'm not really into beige, so I've got some great ones with sparkles in them and psychedelic colours and all these beautiful pantyhose. We got out into the forest and there's all these tiny children tearing around and they're all grabbing an end of the stocking, and I'm explaining how this is the tree root and each child represents a tree that's linking up this mycelial network. And this is where I made fatal flaw number 1. Because I had 18 ends of the stockings and 19 children. So there's this little girl and she's trying to grab an end, and each time she missed out. Some little boy grabbed it and sort of looked at her and she missed out. And her highly intelligent French child response to this was to have a complete and total meltdown. She spins around like a dying fly on her back, legs kicking in the air, screams French expletives at me. I'm thinking, oh my God, why am I working with children? I've never done this before. It's really out of my experience. And so I thought, what am I going to do? Think fast, think fast. So I take off my hard hat. We're all going to wear hard hats, these big shiny yellow hats. And I put it on her head and I said, right, you've got the most important job of all, because you are the forester and you've got to decide which of these trees, i.e. which of the children, you're going to cut down. That was fatal flaw number 2. Because she took about half a millisecond and she eyes off this little guy like this, flies horizontally through the air, grabs him by the throat, pushes him into the ground, he goes flying. And because they're all children, there's so much tension on the network, he goes flying and they all go flying and they all go down. And my friend was right, they're highly intelligent, they understood the concept like that. They got it. And look, of course if we cut down a tree in the forest, all the trees don't fall down. We know that because all the trees got back up and started punching each other. We know that doesn't happen. But simply that, there are implications of everything we do. You know, there's things that we don't see operating on timescales that we don't perceive because we're used to a human timescale, or at microscopic scales that we can't perceive because we don't have a microscope. And unlike the way I grew up, having all these lists of this thing called nature, lists of butterflies and lists of intertidal things and lists of fungi, these kids are thinking systems, processes, interrelations, interactions. That's a whole other way of perceiving. And whether we're talking about, damming this river to make a lovely pond because we want some birds in the backyard or whatever, but what about the plants downstream that are now starved of that water? And I think they're thinking, as they walk into the forest, they're not just unrelated things. There's implications with everything we do. Maybe they're not thinking that quite yet, but I'm hoping one day that this metaphor might stick in their minds. So thank you very much, mycelium holders.